Hi, I'm Dave Blake from EGD, and today we're going to be going through the programming and the diagnostics on the Nice MC824H. That's this panel right here. This is the MCA1 version of this panel, which was released in 2018, and so it will look slightly different to its predecessor. But the MC824H is their 24-volt control panel, which is suitable for their 24-volt motors with built-in encoders. So first off, we're going to go through the inputs and outputs and a bit of the layout on the control panel itself. First off, we've got the inputs down the left-hand side here. So going from the top, we've got close, open and SBS. Now these are command inputs, so these will control the gate's operation. Close will do a movement of close, stop, close. Open will do a movement of open, stop, open. And SBS, which is reference for step by step, will do open, stop, close, stop. So that's the command inputs. The input below that is the stop input. And as you'll see on the left, on the right hand side here, the variations of types of inputs that the stop can monitor. So it can monitor normally open, normally closed, or resistive technology. So for your safety edges, they can be hardwired directly straight into the stop input. In fact, the 8.2 k ohms on the hardwired safety edge can be doubled, so it would halve the resistance value. So you could essentially have two end-of-line safety edges wired into the one stop input, and it will monitor at 4.1 k ohms. The input just below that is labelled blue bus. So if you're familiar with the Nice control panels, you may have heard that term floating around. Blue bus references the type of device. So it's a bus type circuit, so two wire in parallel. But there are various blue bus devices available. So the one device you'll get in your kit will be the blue bus photocells. So they're again two wire photocells, so you can either take a wire from cell to cell, or you can take a cable from each photocell straight back into this blue bus input. On the bottom here, we've got another antenna input. So if the range is limited on the radio receiver that's in your kit and you want to try and boost that range, you can do so with a 433 megahertz tuned antenna in here. The other connections you'll see on the board here are the motor connections at the bottom. So motor connections on the right hand side here, but you'll also see you've got encoder connections here. So you will need a 5-core cable, a 5-core flex to each of the motors. The encoding connections must be connected, you cannot bypass them. And the motor connections are polarity sensitive, so you've got positive and negative, but that positive and negative just simply directs the change of the direction of the motor. The motors that are supplied in the kit, they're not handed, so if you start seeing it going in the wrong direction, or if it's operating with the wrong logic, then you may need to reverse the positive and negative. The other connections here we've got are the outputs. So we've got OGI, which is a courtesy lamp output, which is like a timed output for a set period whilst the gates are opening. ELS, which is the electric light or electric strike. That sends a momentary 12-volt pulse as the gates are beginning, or just before the gates begin to open. And then you've got the flashing lamp output here, which again is low voltage, and that's compatible with the MLBT flashing lamp that Nice supply. So that's the main inputs and outputs on this control panel. The other section that you will need to acknowledge is this bank of dip switches down the left-hand side here. This bank of dip switches adjusts the motor selection for the encoder type that's in the motor. So it adjusts how many pulses are needed to be sent to that particular motor. So at the moment we've got this set up on a Nice Metro motor, the underground, which is dip switch 2 selection. But reference the manual to find out which dip switch selection you need to set for the motor type that you're installing. And so you should only ever have one dip switch switched over to the left. If you haven't got any dip switches set over to the left, then it won't allow you to program the limits correctly. If you've got more than just the one dip switch set over to the left, again, it will prevent you from learning the limits correctly. So that's the main inputs and outputs. In this section, we'll be talking about how to carry out a position search in order to register the open and close limits. So first off, what we're going to do is we're going to press and hold down the open and stop set button until this L1 and L2 LED at the top there starts blinking quicker. Once that starts blinking a bit quicker, it will then move on to L3 and L4, which is indicating that we need to do a position search. So for position searching, when you've got L3 and L4 at the top there blinking, it's telling us it needs to do a learn for the limits. Now, ideally, you want your gate in the midway position. And the reason for that is, it's not mandatory that you have to have it in this position, but the reason or purpose for having it there is so that you know which direction the gate is operating in when you first send it a limit search. Now, we need it for the logic to be correct. You need the gate to run in the closed direction first. Now, as I said previously, the motors aren't handed, so it may be when you've installed this that the motor starts running in the opposite direction. To correct that, all you would need to do is switch around the positive and negative feed to the motor. So when I press and hold down stop, set and close simultaneously, keep them held down for around 6 or 7 seconds, or until you hear a click on the panel, and the motor should start driving to the closed direction, as it is now. Now, if that were to be going to the open direction now, I would interrupt the position search, swap my connections over here, and start again. Now, the motor will be running really slowly at this point because it's learning how many pulses are required for the encoder, and it's learning the torque settings that are required as well. There is a bit of a hack, a cheat for this to increase the speed on the motor whilst you're setting this up. If you're in a high traffic area or something like that, you need to get a position search done quickly. If you press and hold down the stop set button in the center, it does increase the speed to the motor slightly. But you need to make sure you let go before it reaches that open stop and allow it to slowly creep into that stop. So when it's done a full close maneuver, and then when it's done a full open maneuver, the gate will then do another close maneuver, but at its normal speed. As you can see, the L3 and L4 LEDs are still flashing throughout this entire programming procedure. When this is successful and complete, L3 and L4 will stop flashing, L1 and L2 will flash briefly, and then the top row of LEDs will go completely off. In this section, we'll be talking about how to register and program your remote controls. Okay, so now we've got the positions learned, we've got the connected devices learned. The next thing we might want to learn in will be your remote controls. Now, you'll have 2 of these in the kit as standard, and you'll need to learn this or register the remote control with the Oxy BD receiver that's in the kit. Make sure you insert this first, and the LEDs will light up on the top there. That's kind of when you can tell when this is in a learn mode by the LED at the top, and it will be blinking to tell you it's in that learn mode, or it'll be on solid to tell you it's in that learn mode. Now, there's 2 ways we can do this. You can, if you've got multiple sets of gates, there's 2 modes to register this with. First mode is by pressing and holding the learn button down and keeping it held down until that green LED goes solid, and let go. If I was to register this remote control to the receiver now, it will automatically register both channel 1 and channel 2 on the remote control. Channel 1 will operate in step-by-step, and channel 2 will operate the pedestrian mode, or pedestrian function of this gate. So it will open one of the gates partially. If you used to have multiple sets of gates and you wanted, say if you had a horseshoe driveway and you wanted to register channel 1 to one set and channel 2 to the other set, then we're going to need to register them individually. So to do that, simply just press the learn button on the front of the receiver, on the top of the receiver, just once and release this time, and you'll see the LED will start flashing once every second or so. Whilst that LED is flashing, you press and hold the channel you want to learn in on the remote control down, and keep it held down until you get those 3 longer flashes, as shown here. Once you've had those 3 long flashes, it will continue to flash just once a second, until it times out. Now when that LED goes off, the remote is registered and you can now operate the gates with the remote control. Just wait for that to time out and send it an operation. Now you'll notice I pressed it just once and release. Well, that'll register this remote with step by step. So the first trigger will open it, the second trigger will stop it, and the third trigger will close it. If I wanted to register a second channel on this with pedestrian, then you can press this button on the front twice and it will register the remote control with a different behaviour this time. But notice that you've got two flashes on the LED rather than one flash. That's signifying that that input now will register remote control with as a pedestrian mode. But I'm not going to learn that in because I've just got the one small gate on here. Now if you were to make a mistake and you needed to re-register the remote controls, it's a simple way to do that is by pressing and holding down the learn button on the receiver. Wait for it to go solid. It will then go off and then it will start slowly flashing. As it lights up on the fifth flash, you need to let go. 2, 3, 4, 5. You'll get a rapid flash to signify it's successfully cleared the memory. It will go back to its original learn mode and that will have erased the memory on the receiver. So like I say, if you'd have inadvertently registered it in the incorrect method or incorrect kind of type, whether you wanted it to do step by step and instead you've programmed it to be pedestrian, then you can clear the memory on the receiver and start again. So again, I'm just going to quickly show you how to register that remote control. One button press, LED flashes once a second, press and hold it down until you get 3 long flashes. And that's it. In this section, we'll be talking about how to set the auto close. So in setting the auto close, what we need to do is we put this panel into a programming function, a programming mode. And that is by pressing and holding down this stop set button in the center there until you see the L1 LED flash. This will put it into its level 1 programming of parameters. So if you press this, held this down for around 5 seconds or around 3 seconds or so until L1 starts to flash. And let go. Now this flash will indicate whether it's the type of mode it's in at the moment. If I press the stop set button again on this L1, you'll see the rate of flash has changed to a longer flash. And what that means is now that we've set, because L1 represents the auto close mode, what that represents is that we've changed it to now be automatically closing. The default setting for this is around 30 seconds. But what it's left now it's timed out, you'll know that auto close is on by L1 LED being on permanently. So now when I open the gates, after around 30 seconds of being open, the gates will then begin to automatically close. Now for the purpose of the video, I'm not going to wait 30 seconds to show you that, but the gates will auto close now after 30 seconds. In this section, we'll be talking about the blue bus LED and how it can be used to diagnose a fault on the panel. So as you can see, in this section I've added the safety edge, a wired connection to a safety edge here. That wasn't there before. And the reason I'm doing that is for the purpose of demonstrating the LED below that's flashing green once every second or so. That blue bus LED doubles up as a diagnostic LED. So I'm going to quickly register that with the board. And just to kind of highlight how to do that, again, I'm just going to show you, press and hold down open and stop set until L1 and L2 flash quicker. So I'm going to actually mimic a safety edge being triggered, and I'm going to show you what happens to that green LED whilst the gates are in operation. So if I send the gate an open command now, and if I take this safety edge and trigger it whilst it's in operation, you'll see that the green LED has gone from flashing once every second or so to flashing red, and that red flash is indicative of the fault which is currently present. So because I triggered my safety edge, the fault is still going to display and saying what fault it's red, and you'll see it's flashing 4 times between its pause. So 1, 2, 3, 4. So the 4 flashes indicates that the stop input has been triggered. As well as the blue bus LED indicating there's a stop fault, it can also indicate other faults, such as 2 flashes will indicate there's a photocell error. 3 flashes will indicate there is inherent obstacle detection. 10 flashes, it could mean that there's an issue with the encoders on that system, in that it could be obstacle detection by encoder, or it could be the cabling connection to those encoders. There may be a problem there. The worst one, and the one that you don't want to see, is the 7 flash fault. This is usually pretty deadly to that panel. It means that there's a serious malfunction there. It could be water ingress, it could be slug damage. Those suicidal slugs tend to get up through the conduits and onto the back of the PCB where it's nice and warm and crisp themselves up good. So 7 flash fault is not what you want to see. You can try and clear that fault by carrying out a factory default of the panel, which by pressing down the open and close buttons until the top row of LEDs start flashing. But typically 7 flash fault, it means that the panel's duff and you need to replace it. If you've ever got a fault on this panel, first place to check, have a look at your blue bus LED, see what that's doing. That will stay flashing with that fault until the next maneuver is administered. So if I send this another command, you'll see it'll go back to flashing green once every second or so. Just like one. If you want to eliminate that laborious process of all the button pressing and you don't want to refer back to the manuals on which sequence you need to do that in, then you may want to invest in one of these. This is the OVIEW programming tool, which can simply plug into the control panel and give you full access to all of those menu settings. Let me show you how it's done. Okay, so if we plug the OVIEW into this port here where it says IBT4N, there's usually a little knockout here which you can take out before you plug this into. But if you plug that in there, and then you'll get a display with the gate type, the position that the gate is in as well. Now you can register multiple devices to the OVIEW as well with an RJ11 splitter. So if you had 2 sets of gates, you could actually theoretically purchase another IBT4N, plug that in with an RJ11 lead with an RJ11 splitter, and have both sets run back to the one OVIEW, and you can carry out programming via this one OVIEW. You'd simply scroll across at the top between the devices, between the gates, to carry out programming or look at the gate status or event logs, that kind of thing. So I'm just going to quickly show you how quickly it is to program the gates now you've got the OVIEW plugged in. If you simply go to the menu by pressing that right button there, C unit functions, the top one, C unit functions again, and then it will give you the list of functions which you can carry out, you can execute on this control panel. So the first level that we want to carry out will be a Blue Bus Learn, which learns all devices connecting to your Blue Bus input and to your stop input. So to do that, we need to go into Installation and select Blue Bus Search. Ready for execution. If I click Run, you'll see then L1 and L2 on the board will start flashing. That's indicating that it's learning the connected devices on that panel. When that L1 and L2 stops flashing and goes back to its normal status, that means it's registered the devices. If I click back on my OVIEW now, I can check that I've got the right motor selection by going onto motor type, which is now displaying the ME3024, which is what I've got in. If I go back, I can then go into my position search. Now, I already know that the direction of this motor is running correctly, but when you go into a position search, typically you want the gate halfway, just so you know which direction it's running in. It needs to go to the closed direction first. Because this gate is already closed, it will still try and run to the closed position, but it might not be obvious if you're out on site. So again, it'll go to the closed position first, then it will run to the open position, and as I said previously, it'll be running very slowly at this stage. You can increase that speed by pressing and holding down the stop set, but you make sure you let go of this before it reaches the slow down areas, and the reason for that is just so it doesn't crash into the stops. When it reaches the open stop, it will then close at the normal speed. And again, this on the OVIEW is just displaying operation in progress there. As soon as it's finished, it will say ready to execute again. And once that finally comes back to that closed position, L3 and L4 are stop flashing, L1 and L2 are briefly flash, and then it will go back to its normal state. So much quicker, much easier to remember on how to do that, because you've just got a simple English menu that pops up there that you can select the executions that you want to carry out. So that's the basic setup of it. We've done a Bluebus search, checked the motor type, done a position search. There are other settings on here as well you can go into, such as your standard parameters, which we set the auto close on before. But if I go into here, you'll also see you can adjust the pause time to the second. So I can set, that's currently set to 30. Let's say I want to change that down to 5 seconds. Simply change that to 5 and press OK. You got reclose after photo as well. So if I turned my pause time up to 3 minutes, but then my reclose after photo on, then basically if I set my reclose after photo to 5 seconds, when someone drives through the photocells, the gates will then close after 5 seconds. But typically they would stay open for the length that I'd set on my normal auto close. Always close is a feature which basically, if there's ever a power cut and the gates are stuck in the open position, then when the power comes back on, the first thing the control panel will do is send the close command to the gates to get them shut. You've also got advanced parameters on this, which will allow you to edit the input configuration and output configuration. The only reason you may, or the purpose you may be using this for, is if you've got additional photocells, or if you've got, if you want to change the output configuration, you can change the output of the courtesy lamp to be a traffic light. There are various kind of outputs that you can select for this. At the moment it's set to flashing lights, but you can change it so that basically there's 12-volt pulse that's sent out whilst the gates are in the open position, or you can change it to another electric lock, red traffic lights, green traffic lights, etc., etc. I'm not going to select any of those, I'm just going to leave them as they are. So the other section on this output configuration is the electric lock time. Typically that's set to 2 usually, but if you had a mag lock connected to your gate system there, you wanted it to release for a bit longer, just so it didn't snatch back just as soon as the gates had started opening, you can increase that time to however long a period that you want it to. When you go into input configuration there, the reason you may want to change some of the input configuration, or one of the reasons for it anyway, is if we go into the close input, which is rarely used on the board. There's not many occasions when you'd hardwire a command just to close only. But you can change this to any of the others, so you can change the close input to an open, or a step-by-step, or a pedestrian mode input. Or what you can do is change this to photo. So it can monitor then relay photocells in place of the Bluebus photocells. The diagnostics will still be the same on the Bluebus LED. So if there was a photocell error, you'd still get the 2 flash fault on the LED. But now you can change a normally open, what normally typically monitors a normally open contact, to an input which monitors a normally closed contact. But I'm just going to leave that as it is. So as you can see, the programming on the OVIEW is much quicker and much easier to navigate through the menus if you need to change any of the more advanced parameters. Now you can use this in the household as well, so you can have this so you can operate the gates from it as well. So if I go into options, commands, and send the gate step by step, etc. The other benefit with the OVIEW as well is if I go into the menus on here and go into C unit functions and then go into advanced functions, There's also an event log which you can go through to find out what fault has been present. So yeah, there's if you've got like an intermittent fault with the gate system there, which is only happening every now and then you could leave your OVIEW plugged in over the weekend or something like that, wait for the fault to be reported, go back to your OVIEW, find out what time it was or what date it was that you had the fault occur, go back through, and then you can find out, well, it was a stop input fault, or if it was a photocell input error, that kind of thing. So yeah, that's pretty much sums up the benefits with using one of these tools. Typically, it's great if you're doing multiple installs with the Nice products. It's compatible with all their Nice 24-volt control panels, and it's now compatible with their newer Nice MC800 control panel as well. So that's the basics on this control panel. However, there are a multitude of parameters you can adjust and change depending on the installation requirements for your site. I can go into them in a lot more detail, but this video will be far too long. If you want to get in touch with us with any specific requests or technical requests, please contact us on the details below. Don't forget to follow us on our social media as well for the latest in industry news and latest offers.